So I will get going now, just so we can move this on quickly and get to the real meat of the program. This is the fourth part, Building a Cyber Range, conducted by Kevin Cargo. My name is Paul Siegel. Again, this program is being recorded, so you can come back and review it later on. I'm going to spend about 2 minutes telling you a little about us, and so that gives you a flavor of the organization that's presenting this and what we're all about. The company's called Starweaver. We are an organization focused on fintech education, both live and in person. And we focus almost exclusively on large institutions, government agencies. You can see we pretty much have covered every continent in the world. A lot of what we do is covered on the slide, whether it's cutting-edge tech IT or traditional enterprise IT or project management. We also do finance, banking, and business skills. As you see in the upper right-hand corner, live and recorded, live in person. We run programs all the time. Pretty much every week we've got a few dozen programs running somewhere in the world. The idea is to have it driven by practitioners, people like Kevin, in this case is a guy named Dan Burnett, but who are real experts in the field, who know it deeply, and therefore can give you real-world experience, practical hands-on education. The goal here, again, is to talk about some other Institute programs. The one you see in the center is the CyberWarrior certification. We have some others on the Institute. If you're interested, please do take advantage and take a look. Again, we are doing a cybersecurity program. I say we, meaning Kevin. It is a program that is about an hour, lots of time for Q&A. If you have questions, post them on the right there. They're recorded afterwards. There'll be a short test at the end of 25 questions, end of the program itself, not the end of this week, this day. But you'll have an ability to go back and review that and review the content. So all the questions will be taken from this program itself. Again, we're on the fourth component here. These are learning outcomes. Is about building a cyber range, and Kevin will get into that detail. The green have already been done of the cyber schedule. The orange is the one you're doing today, and there's 3 more coming up. Dates are available on our website as well. Kevin will tell you about himself. I think it's been pretty much shown that he is a guru in this field, and if there's any question he can't answer, you will shock me. Here are some of the upcoming programs that are not the security programs. There's a World According to DevOps. It's coming up on the 26th of May. We're starting our FinTech talks in the middle of June. You'll see me posted on that, and there's a TOGAF program. Again, fill out the feedback link, which I'll post in the right chat window. You'll get access to one of these courses for free for life. Not a bad thing, just for giving us a little feedback and tell us how we're doing. Okay, I'll post that link. Again, if you have any questions, just contact us. And with that, I will pass this on to Kevin so he can jump into the program and lead you away. Hang on one second, and we will pass this on to Kevin. And there you go.
Okay, thanks for that, Paul. Let me get my screen set up here. Now, hopefully everybody can see my PowerPoint slides. I won't spend too much on my background because I always run out of time. So basically 25 years of professional security testing, and what I do is today is I do a lot of assessments around the world, the globe, those types of things. And what I want to do in this presentation is talk to you about the need for a cyber range. And the biggest thing you got to remember is you're going to have to build an environment to practice your skills. So we continue to do an actual type of training sessions, and we go through a lot of different types of topics. As one of the comments has been, it's a lot of information on an hour. That's one of our challenges. But what I try to do is give you those processes so you can actually apply those. And in this actual presentation, it's all about applying those skills. And hopefully I'll still have some time at the end to demo some things, because I know the demos are always an important part as well. So let's go ahead and get started. So the first thing you have to do, especially if you're going to be doing either defense or offense, so what happens is you're going to have to, what happened there, screens? Well, hang on a minute, I guess we lost it. Okay, so back here, I don't know why it lost it all of a sudden. So vulnerability sites, okay? So with vulnerability sites, Windows on top of the, hang on a minute here. It's pausing my screen. All right, let me just share there. Hopefully now you can see the whole screen. It keeps telling me it's coming. Anyway, vulnerability sites. Zero Day Initiative is a good site. Security Focus is a good site. National Vulnerability Database. These are just a couple of reference sites. It's really up to you what sites you want to use. But the key, if you're doing defense or if you're doing hacking, is you want to go out and you want to explore. You want to find the latest vulnerabilities that are out there, the latest information that's out there, and then once you have that information, that's where it comes to building a cyber range. You're going to take that information and you're going to emulate it. You want to create
Kevin,
it.
I just want to mention, it's Paul. You're not showing. Apparently, you're just showing like your desktop. Maybe you have two monitors. You may want to go back and start that again. Sorry about that.
All right. So, all right, no problem. So. About that. Do you see the display now?
We're good now. Yeah, we're good.
All right. So yeah, I do have two monitors, and I apologize that it was listing the wrong one. So the vulnerability sites are the key. You want to go track the vulnerabilities, those types of things. And once you discover a vulnerability that either you have and you want to defend against, or if you want to go out and you want to actually learn how to attack, these sites will help you get those types of vulnerabilities. And then you look for different ways to test them, be it exploits or anything like that. So your initial research, even if you're doing defense, is to know your vulnerabilities, right? So that's part of what cyber range is all about. I have to have vulnerabilities to either test them of an offensive standpoint, or I have to have them from a defensive standpoint where I want to actually defend against those vulnerabilities. So that's the goal. Okay, so let's talk about this. So in a lab environment, it's essential because if you want to practice your hacking and defense, you have to have a lab environment. Once you have that lab environment, it allows you to practice these different types of things and see what works and doesn't work, all right? So if you attack the sites out on the internet, that's the same as a malicious hacker. Not only that, it's illegal. You don't want to do anything that's illegal because the only thing between a malicious and an ethical hacker or a professional security tester is the written authorization and permission. So the preferred method, of course, is to use virtual machines. If you have an entire environment at home, you can build a lab with separate machines, but the preferred method is the virtual machines. Well, why? Because I can keep it all self-contained within a laptop, which I'm on my laptop now, and when I show you all my virtual machines, you'll see what I'm talking about. I can literally build or emulate any environment of any customer or client. So that's the goal. You want to be able to build an environment, and when you test that environment, you want to be able to verify it works. Okay, so why do we use virtual machines? Well, the need for separate machines is eliminated. That's the most important thing when we get into building an environment. And you can emulate, as I said, any architecture. But more importantly, I can build complex networks. And what I want you to understand is no matter what the actual enterprise is, if it's 2 firewalls, if it's 1 firewall, or however it's set up, I can set up a virtual environment that shows me the same thing. And by doing that, now I can actually test it. And it's a test platform. And the nice thing is I can create and store multiple images, or what they call snapshots in most virtual terms. Now, the thing with this is it's an extremely important way to surf the internet securely, because what I can do is I can actually go to the internet from my virtual machine, do whatever I want, and as long as I have a snapshot of the machine before I started it and connected it to the internet, I hit revert or get back to the snapshot image, and when I do that, that snapshot image actually has nothing on it. It's clean, just like when I started. And that's really the best thing you want to be able to do. You want to be able to create images, test things, but before you test them, have a way to get back to the beginning. That's really what engineering is all about. Engineering is all about creating a method where when I'm testing, I can always get back to the point I started at, or the last known good point. And this is where virtual machines excel. So this is the open source tool VirtualBox. So as you see here, I've got a number of different virtual machines. You've got Kali over here. I've got a W2003, which is actually a Windows Server 2003, Broken Web Applications virtual machine. I'll talk about in a little bit. A router, a Bastion host, and Mint Linux because it's installed it, and then another box called K1, which is Keyoptrix, and I'll talk about that. So this is how you set up your virtual environment. And here I've only got one adapter, one network card, right, in this K1 V1 machine. So once I've done this and I create the actual network switches, and we'll get into this in a moment, as long as I connect anything to that switch, it can talk to each other, right? So now that allows me to build these complex virtual environments, as you'll see. HyperV, Windows has HyperV. It's free. It's included with most of your versions of Windows. It's similar to VMware and VirtualBox, but it's not as robust. It's a feature, so if you have Windows 10, Server 2008, Server 2012, you can try it out. But my challenge is it doesn't give me the networking as well as VirtualBox or VMware. And once you get the networking and tool integration working, it's a legitimate alternative. But it takes a lot of work to set up HyperV to build these complex environments. And what we're talking about here is multiple switches. So when you get multiple switches, you get multiple machines, you get all these types of things, it's a little bit more difficult to set these types of environments up. So VMware Workstation Pro, it's a commercial one, so you have to pay for it. But I like it because you can run multiple desktops and servers at the same time, right? I think it's $249 retail today. But if you register at VMware, usually at your birthday, they send you a coupon. I think I got mine for 30% off. So it's always worth, like you can get a 30-day or a 60-day trial, try it out. And it allows you to connect virtual machines and simulate network environments. And that's what we want to be able to do. Now, you can do the same thing in VirtualBox, but again, VirtualBox still, in my opinion, just my opinion, doesn't have the robustness of the networking that VMware does. So it depends on how much you're going to be building these and how much work you want to have to do. And you archive your test environments, which I said, you just build them, you take snapshots. And once you take a snapshot, that's the given state of the machine at that time. Works very well for malware analysis or memory analysis and those types of things. So you can create a new machine. You can clone it from an existing image, which I like to do because I clone a lot of different machines. And what I do there is I'll create a machine, put one form of maybe a virus or a worm, depending on what I'm testing on it, and take a snapshot. And then I'll clone the machine and put another form on it and take a snapshot. And if you keep doing these clones, you've got different images of it. The difference with a snapshot is when you revert to the snapshot, you've lost the previous one unless you have a snapshot of it. With a clone, once you clone it, you've always got the existing pristine state of the machine before the clone, which is very good. Now, there's a lot of pre-built ones out there. You can go on the internet, do a search for pre-built virtual machines. I got one I'll show you, OWASP Broken Web Application Machine coming up, Metasploitable 2 from Rapid7, and Keyoptrix. And then there's an OpenVAS for creating your own vulnerability scanner virtual machine if you don't want to go pay for a commercial tool, and OpenVAS works very well as well. So the key, though, is the virtual switches. That allows us to connect to our other components. With VMware, you can create up to 20 of these, which is more than you'll probably ever need. And when you create the actual virtual machine environment, so when you install VMware, it creates 3 default switches. VMnet 0, which is bridged, and I'll explain each one of these coming up. VMnet 8, which is NAT, or Network Address Translation, and VMnet 1, which is host only. So DHCP Server provides IP addresses to the switches. So you can actually put a DHCP server, there's one by default, on all the switches in VMware. And once you've done that, VMware will assign IP addresses to any machine you power on that's connected to that switch. And that's why I said, once you build the environment and you have your infrastructure, you just connect any machine to that switch. And if you've got the DHCP server running, it's provided an IP address, and you are on the network and be able to talk to each machine on that switch without any problems. As I said, you can have the 20 network adapters. This allows for very complex architectures, multiple layers. This is what a bridged environment looks like. So what happens in a bridged environment is the virtual machine is connected to the virtual network switch to your bridged adapter of your host. What that means is there's no DHCP server in VMnet 0 or the bridged environment because it's connected to the physical network. So by connecting to the physical network, it's got to get its address from the physical network. So there has to be a DHCP server on the physical network, or you have to do a static configuration of the IP address. Again, totally up to you with your personal preference. The one downside of bridged is, because it is bridged, it's another node on the network, which means the virtual machine is directly accessible on the network. Sometimes we don't want to have that. Then it's connected to the physical network, as I said. Now NAT, network address translation, now the virtual network adapter shares the actual switch with the host adapter. Now what we like about NAT is they can't route directly to you from the internet unless the host allows them in, which you would have to configure. But you can go to the internet and use the internet while your adapter is set to network address translation. So it gives you a little bit more protection, but still there is traffic, malware, everything else that can download to the machine that's on a NAT virtual switch. So for those, what we do is host only. And host only is the network completely contained within the host. So now it's isolated. Again, the default one is called VMnet 1. And you see here you got DHCP server, right, in the virtual machine, the host network adapter. All these are things you can set up in private with the virtual machines. This allows us to create those completely isolated environments, just like you can do with an actual physical network where you control the zones and the segments on the actual network. And that's the key with building your own range. You want to build segments, and each segment set up and configure it based on what you're trying to do. If you're trying to learn defense, how you learn defense, those types of things, okay? And you can isolate a network. That's what we like about this. You can literally isolate a network, and when you isolate that network, nobody can access you on that network, all right? That's the goal, isolation, because then I can test it. And I've talked about this concept before. Segmentation isolation. And segmentation isolation is nothing new, but it's very important. I've told people this analogy before. When we put internet access to ships, we did not put the same network on the internet. We didn't put the missile control system on the same network as the internet. And that's the concept of segmentation isolation. As we continue to build your skills, we'll talk more and more about that. We've also covered it in previous webinars. And you cannot connect to the internet. That's the goal here of host only. There's no way it can connect to the internet, and that helps isolate and protect your environment. So what's it all mean? I can build sophisticated networks. So when you look at this, I have VMnet 0, VMnet 2, and VMnet 3. And effectively, the host adapter here that I'm pointing out now is connected to the network of the physical network. So I can have all these machines out here, but I can have this entire test environment in here. So let's take a look at this. I have virtual network switch VMnet 0, which is bridged to the host adapter. And then I've got a firewall machine. So right here's a firewall machine with 2 network cards. So it's a dual home network firewall machine. And this firewall machine could be any device you want to test. That's what we love about virtualization. And I'll talk about some of the different tools. But if you go out and you download software and you want to test it, say you want to test pfSense, you want to test Untangle, you want to test these other products that are out there that give you virtual and they give you firewall capability. You can build it in a virtual environment and test it. So in this case, I've got a firewall here with 2 network adapters, and the power is anybody out here in this physical network has to get through this first firewall to get to this web server. So I can put in rules and test this web server, right? So I can put in a rule that says allow port 80 traffic to this web server, just like you do in a DMZ or demilitarized zone segment on your network. So I can do the same exact thing in a virtual environment. And then we got VMnet 2 here, and that's got another machine, right, with 2 network cards. Why? It's a second firewall. Very common, very popular today in the networks you come up against, and especially a testing environment. They have 2 firewalls, and that's what we're showing here. You have 2 firewalls. Another name for these firewalls in firewall network design speak is a bastion host. So what it is we have 2 bastion hosts. And a bastion is just something I have to get through or around to get to the other side. Think of it that way. So this is a bastion host. This is a bastion host. So when you start looking here, what do I have? I have 3 switches and 4 virtual machines because I got an internal PC. So what I've done here, I've set up a 2-layer defense network architecture, right, using 2 firewalls. And I've got a DMZ, which I can test all my public web server access right here in the DMZ, and I've got an internal machine where I can test internal to outside access as well as internal to web server access, as well as attacks from the outside trying to get all the way into this internal PC. In most cases it can't because of the addressing requirements, but again, this is the beauty and the power of virtualization and what you want to be able to do to build your cyber range. You want to create these types of custom, sophisticated networks to test any environment you have to test. So we have more components. If we want a router, if you don't have a device, you can use a tool called Dynamips. Dynagen.org requires the Cisco IOS. The GUI front end of that is called GNS3. Zero Shell is another one. Or you can just set up IP tables. You can put IP tables. IP tables have stateful rules. So you can set up IP tables, put in stateful rules, and control what traffic goes in and out of your environment. Remember our diagram. We had 2 firewalls. So I could select one firewall and I could put a router there instead of a firewall. I have that flexibility, which is what we like to have in our range, because maybe I have to test a Cisco router. So I need to get a Cisco IOS, set up Dynamips, and start testing that Cisco router. Or from the standpoint of defense, I want to harden that Cisco router, implement secure shell on it, those types of things. Once I build it in a virtual environment, I can do all those things. Okay? The Bastion host, as I said, can be any actual product that's out there. There's 2 examples here I put on here. Smoothwall, one of the ones I like. It's a free version. Works very well. Very simple to set up. Has some good features of it. pfSense is another one I like a lot, which is based on FreeBSD. Has load balancing, which you can integrate with the actual high availability proxy. All these are powerful things you can do to not just test, but also work on your defense. How you're going to defend your networks from attack and those types of things. And then once you do these firewalls or these Bastion hosts, build them with 3 or 4 interfaces. That is, the red interface, as it stands, is the untrusted outside world, the external attack vector, if you will. The green interface is the internal or the trusted world. And the orange interface is your demilitarized zone, or the DMZ, which is the place we recommend you put your public services on. Then you add that 4th interface if you've got some wireless testing you have to do, and you have to put a wireless segment where people are coming in from a wireless network into an actual wireless router, wireless controller, or whatever. Remember, wireless is bridge to wired. So no matter where wireless is being used, there's a bridge to the wired side. By setting up the purple side, that's your bridge to the wireless world, but you still have the actual Bastion host to protect the other segments of your network. And that's the way we do that. So what's some components? You want to build an attacker machine. Now you can get out Kali Linux. You can go get another one called Pen2 or Parrot, or you can build your own custom machine. Again, it's all how much effort you want to put into creating the actual virtual environment and creating the different machines. Personal preference, of course. And then an inside machine. You need a Windows machine that is going to serve as an inside user. Almost everybody out there, pretty much, predominantly in the corporate environment especially, the users are using Windows. So you put those Windows machines in your inside segment, otherwise known as your green segment. If you remember, we are purple, our green, and our orange that we talked about, and then our red. So we had 4 possible segments. The green segment is where the inside machines are going to go. And that's normally where you put Windows machines so you can do different types of testing there. And all boxes with at least 2 network cards. Why? Because you can bind and isolate attacks as needed. That's one of the keys here. You can bind and isolate the attacks. So what do I mean by that? I can set up a network card on one and bind it to one segment and only allow attacks from that segment. That's the power of using binding and isolation. I don't have to have the network card bound to the wild card of 0000 like some people say. No, I can bind it to a specific interface that is facing a segment, which is powerful ways to segmentation and isolation. Start your research, build your lab, and test it. Vulnerability sites, exploit sites, depending on if you're on the offensive side or the defensive side. The cyber range is interchangeable. You can use it on offense, you can use it on defense. So you have all these different capabilities that are out there for your environment. One of my favorites, OWASP Broken Web Application Project. It's a collection of all your web tutorials, very good web tutorials in this. And WebGoat from the OWASP group is a good tutorial to practice your web application testing with. You also had the Damn Vulnerable Web App, which is another good one to test with. And you have .NET WebGoat, which gives you even more types of testing, but it's .NET based. Okay, this is what it looks like. So when you see here, it's got entire areas of testing for training applications. So there's a whole list of these, of Matildae, all these other types of testing environments. So once you put this up on your environment, it's a virtual machine. So once that virtual machine goes on your environment, you have a testing platform to test all these different types of attacks. Metasploitable 2 from Rapid7. This has pretty much every segment of a vector of an attack you can think of. There's all kinds of different segments, things like that I can test using Metasploitable 2. Multiple backdoors, vulnerable web services, Chioptrics, virtual machines with different levels. Multiple levels. Here we've got 1.1, 1.2, 1.3, and they're VM from 2014. Again, they're platforms that you can set up that are already built. You can also build your own targets, right? So when you do your research and you find a new vulnerability, if you can't find a machine with that software on it, there's plenty of places to get that software, put it on your virtual machine, and you can start testing that vulnerability. Or better yet, if you have a training lab environment set up that emulates your architecture, as soon as that new vulnerability comes out, or a new exploit comes out for that vulnerability, you can test it in the lab environment and know where your risk is and what's the risk to that segment. If that segment's under high risk, you can actually go ahead and isolate that segment and monitor it, increase the monitoring, and do additional things to help mitigate the risk from that segment. Different levels of machines. So you get different levels of machines to practice with. And again, they don't tell you what the actual vector of attack is. You boot the machine up and then you have to figure it out or research on the internet and find somebody who's posted a solution on it. That's how we practice our skills. That's how we practice the process we've been talking about throughout the series. This is OpenVAS. They now have Greenville Security Manager given a Community Edition, which used to be a separate actual virtual machine, but it's worth checking out. If you want to actually build it, you can go in and actually build this machine and set up the different types of things. Again, everybody has different preferences because Kali Linux has OpenVAS on it as well. In the latest version, OpenVAS 9 is working very well. It's much faster environment and working much better than OWASP. OpenVAS version 8 did. So it's an improvement. And again, when they're free, they're open source, it just takes a little bit more time to get the actual updates, those types of things. But again, we have usually two to three tools is what the recommendation is. I pick 2 to 3 tools. Once I have those, I learn those tools and master them. That's the goal. Installed and set up for usage, pretty easy to do, okay? All right, Network Security Toolkit, one of my favorite. Why is it my favorite? The easiest setup of snort that you'll ever do. 2 clicks of the mouse. You got to wait 10 seconds for each click of the mouse, but 2 clicks of the mouse, and you're literally going to have a full-blown snort with an actual GUI using base, right? So again, very powerful tool. Most of the top 125 security tools out there, and they've created a what they call a WUI, a web user interface. Makes it easier to work with the tools. Why? Because it's form-based, so you can concentrate on how the tools and the process and not have to learn the nuances of the tools. It's a good place to start. If you haven't seen it before, I don't have the URL here, but it's easy to find, www.networksecuritytoolkit.org. And when you go there, you download it, and you can create the actual virtual machine, and you have all this nice GUI environment. Easy to set up a Snort, as I said, because it's 2 clicks of the mouse. Snort is very popular. It was purchased, SourceFire, the parent company, was actually purchased by Cisco. So you have Cisco using the type of Snort rules, those types of things. And it's excellent to practice your evasion if you're doing offensive tactics and trying to figure out a way how you're going to cover your tracks and evade. This is what it looks like, and there it is. As it says, it's up to version 24. And if you look down here, geolocation and graphic tool matrix. So at all this geolocation, there's tutorials on here. Over here, you have a multi-tap network packet capture, which is a great way to set up your monitoring environment for the segments when you build them. This is how you test it. This is how you test those types of things. We used to have what's called teams in VMware, but today they have folders. It's replaced the teams. What it is it allows you to power on and off complex ranges all with one click. Because one of the problems is if you start building these ranges and you have 10 machines, it's going to take you a while to power them up. So what you can do is build a folder and put all those machines in the folder, and when you click power on, all the machines come up. So your entire range is all powered up with one click and shut down with one click, right? So again, it's a powerful way to set up our environment. And this is what it looks like here. So as you see here, I've created an actual team or folder. I've called it test, and it's got a clone of OWASP, Broken Web Applications, a virtual machine in it, a Debian box, and a FreeBSD box. So again, these are different ways to set up environments. So all you have to do is click on it, and once you click on it, you're good to go. Planning. When you do your information gathering, we talked about the steps introducing the hacking methodology in previous webinars, but the main thing is information gathering is non-intrusive target search. What can I find on the internet? What can I use on the internet? And what can I leverage? Okay, we identify the systems and services and the software, right? And then you lab it up. And you play. This is the key. The research, the process, everything you do doesn't change. What changes is the vulnerabilities, the targets, and the tools you use. So once you have the process down, you start experiencing the different tools. You pick your favorite tools. As I said, 2 to 3 tools. Once you get to 2 to 3 tools, you decide what you're going to use in your environment, and that's how you set it up. And you build it, and then you play with it to see what works and doesn't work. That's professional security testing, and it's also defense, because once you have the range built and you test it, you can turn around and switch your hat, if you will, and you can test the defense of it and see what works and doesn't work from a defense standpoint. Once you're ready, start with a flat network. Find a vulnerability, find a new exploit, put it on a switch that's directly connected on a flat network. Why? Because if you can't get it with a flat network, you're never going to get it through a firewall or through a router or through some other form of a defense mechanism. So always when you lab it up and play, test it flat first. This is why it's recommended to have 2 network cards. One network card can represent the flat network segment, and the other network card can represent the segment or the layer of where the segment or the machine is located in your network architecture. This is the power of how we do our network ranges. And when we set this up, we can build any environment. And that's the power of building your own cyber range. You can set up any environment you want. Document what works and does not work. Make sure you keep good records, copious notes. Make sure you know what's working and what's not working. Once you know that, perfect it, improve it, build your skill set, get more experience. So when you go into the environment, you've practiced it so many times over and over again, you're good at it. It's kind of like driving. The more you drive, the better you get. It's the same here. The more you work with the process, you apply the process to your range you have built, the better you will be at a professional security tester or even a defense administrator, because when you take that hacking mindset and you start attacking your range, now you learn what works and doesn't work from a defense standpoint, and that's powerful stuff. So we look at this virtual design here. This is a simple setup of setup, very simple. And you've got the NAT, network address translation, and you got an attacker box connected to it there in red. And then you got VMnet 2 coming out of a router. So we got a router here. And then we got a Bastion host. This could be smooth wall, as I said, or it could be pfSense. Anything you want. And then you got your machine on your internal network. So just this simple design here, 4 switches, 4 machines with the router. So 4 switches, 4 machines. You've got another architecture, but this one has a router. The previous one had 2 firewalls, right? And then all you do is you plug in machines to any one of these segments, right? So that's the beauty of doing this type of environment when you build it. Once you have this, you can build any segment, any level, any layer, and emulate any enterprise. I do my advanced network defense course, which I talk about at the end. And what we do is we build an entire multi-layered enterprise network in the class, in the 4 days of the class, and then we test it like a penetration tester does at each segment. At each segment where we penetration test it, after we break it, we defend against it. Or in some cases, we can't defend against it, but we identify the infection, do a memory analysis like this internal machine here. We know users are going to click. So if a user clicks, we're going to get malware on this machine down here, this internal machine. If we get malware on that internal machine, we have to do memory analysis. Just by setting up this environment, you have that capability with virtual machines. In VMware, you just pause the virtual machine once it's infected, and you take an image of the RAM. Or just take the vmem file, and the vmem file represents the RAM in the virtual machine, and then you have your environment. Okay? Now, another important thing to be able to do is when I'm running all these attacks, capture it. We talked about Wireshark, those types of things. Capture the network traffic and then replay it. And that's what we're showing here. Using the tool TCP Replay, I can replay. In this case, I'm replaying the hacking trace from DEF CON, and I'm replaying it at 2 times the normal speed. Once we build it, capability to replay information from our testing. So I don't have to keep running those attacks all the time, especially when I'm doing monitoring defense. I can have an environment where I just replay what I've already recorded. All right? Easiest way, use TCP Replay. Okay, TCP Replay. Here's the man page for it. Won't spend too much time here because I want to do a demo still. And there I am replaying on interface 1. To my ETH0 capture.pcap. That's a capture file. I sent 81 packets out, and they successfully went out in 91 seconds at 111.8 bits per second, right? But again, I can replay as fast or as slow as I want to. I can replay it 1 packet at a time. So once I build this environment and set it up, I have the power to replay any type of attack I want to either monitor, defend against, or see how it works at a memory infection. So I've got the capability to do all that just by setting up what we want to set up. This is powerful stuff. For those of you who prefer a GUI, I understand some people out there would rather just have a GUI. Give me a graphical user interface and that type of thing, and that's fine. It's not a problem. Those of you who prefer a GUI, I recommend you take a look at Colasoft. Colasoft has a great protocol analyzer called CAPSA. Their CAPSA protocol analyzer is actually something that you have to pay for. It's a commercial tool, but they have some free tools as well. And this one here that's on the display right now, Colasoft Packet Player. It's like TCP Replay, but as you see, it's a GUI environment. And you just select the adapter, the file you want to play, and information you want, and you send it. And you can do all kinds of play speeds. You can loop it, do delays, right? All these different types of things. So again, it gives you that capability to test and build all your range parameters on your environment. And it works very well. And as I said, it's free. It's great that it's a free tool. They also have a packet crafting tool you can go if you don't want to manually create packets, and you can create packets with that tool as well. Another great feature. So let's do a demo. Let's see if we can get the demo gods to smile today. So let me go to my VMware workstation. So this is VMware. So before I start the demo, I'll give you an idea. If I go edit, virtual network editor. These are where you create your switches. Right now I've got on this machine 5 virtual networks, and these are the different IP addresses, right? And there's where I set up the DHCP server, right? If I hit change settings, it's got to go to admin. So once it goes to admin, now I see VMnet 0, which is automatically bridged. And this is just network environments. So if I click add network, here's all the different networks I can add. Remember, I can add up to 20 of these, more than you'll ever need. Right? So it's very easy to do, and there's a lot of advanced features you can do with this. For the first part of the demonstration, what we're going to do here, we're going to take our router. So I've got my Dynamips router right here. And remember, you have to have a Cisco IOS for this, but you can do it with IP tables. And then I'm just going to start it on port 7200. So that loads the actual router. As you see, hypervisor, TCP control server started port 7200. So that's good to go. So now the next thing I want to do is I'm going to create the configuration file. So I've already moored the configuration file, you can see. And right here's the main thing. We've got this router, R1, and it's connected to ETH0 and ETH1, and they're connected to F00, which is the external interface of the router, and F10, which is the internal interface of the router. So this is how we set up these complex architectures. Now we're going to route traffic between these two networks. Now again, we could do this with IP tables just as easy. So now all I have to do is to start Dynagen. So it's just Dynagen config, the name of the config file, .net. That starts it up. As you see here, it's loading, and right there, this prompt is going to give us the actual capability. So what we're going to do here is we're going to, so this prompt is going to give us the capability to access the router. So we just go console R1. That's like logging in with a console cable. So now when you look at this, it's right here. And then all I have to do is hit enter a few times. That starts up the router, enable mode, conf T for configuration. And then I can configure show IP interface brief, and it's just the standard Cisco configurations. So now you see I got 4 interfaces. 2 of them are assigned. One's to my NAT network, that's this, and one's to my other inside network, and that's it. This router now is full-blown ready to go. If I go show run, it'll show me the actual running configuration with the interfaces and the configuration of the interfaces as well. So now in my actual range, I have the capability now to emulate or set up any type of access control list for any type of environment I want to test. And that's what we like about building our own cyber range, right? So this is done. We've got the router. Now I want to run you through the process of using our cyber range to do practice for penetration testing and things like that. So if I come over here, and this is Kali Linux. Kali Linux, well known to many people for network mapping, that type of stuff. So I'm going to map the actual open ports of a target machine that I've set up. So as I look at this, I see I have all these ports that are open. Well, this is an attack surface, right? So as an attacker, when I'm emulating an attacker threat, I want to look at the attack surface. So now I know these ports are open. What I want to know next is what's contained or within those ports. And that's what I'm doing now is with this vScan. And you see the vScan here. Now I've got more information about the information on the port. And I have something very interesting here. I've got a nice little Samba actual type of thing. So I've got Samba running on this machine. So in this case, this version of Samba, I could go look for vulnerabilities. Right? So I'll bring up a target here that I know has got an actual vulnerability on it, so I can demonstrate that. It won't take long to boot up here as I'm booting it up. But as I'm booting it up, I'll explain this further. So now what we've done is we've enumerated or gathered additional information about this target. Right? So these are the goals when we're doing these types of things. So when I set up this type of environment, as you see, I've got all these different types of machines. If I show you on my machine here, look at all the different virtual machines I have. I have all these different virtual machines that I can configure and test in my range. And that's the power of what we're doing here. So I'm just going to save some time and get the actual IP address of this, and it's 104. So now I go back to my target, or sorry, my Kali box, clear the screen so I can see a little bit better. And now I do the scan, but I change my target to 104. And again, we're looking at the attack surface. So from an attacker standpoint, I've got to look for what's connected to these ports and if it's potentially going to give me a vulnerability, which will allow me to have it a vector for an actual attack. And that's the goal of this. And that's what I'm trying to do right here. So now as you see, I got Samba again, but this time I don't have the Samba version. I got to use a little bit more work to get the Samba version. So I use a tool called SMB Client. So SMB client-L will connect to the actual anonymous null connection. All right, so I do -L and I give it an IP address. So what I do here is I give it the IP address of the target. And it gives me the Samba version because it allows the anonymous null connection. And that's the goal here, is to find out what is actually the targets are telling us. As I've said in other webinars, and I'll say it again, the process hasn't changed. So now the next thing I do is I just go in here and I do a search of the local exploit database. And it's called search exploit. Samba, and I don't want a local vulnerability, I want remote. So I just do Samba remote. And when I do this, there's a whole listing of all these different types of exploits. So you're probably wondering, well, how do you figure out which one works? Well, you do your research and you look for one that matches the one that you found in your research. As you see here, in this case, Linux remote 10.c. So what I do is I just copy it over to my OPT folder, which I've already done to help. And as you see there, I got an executable called Samba. If I more 10.c, there's the code. So there's the actual code and information for the exploit. So once I compile it, I just do /Samba. And it tells me how to use it. And it says use a B with a 0 for Linux and then give it the target. If all goes well, I get a root shell. And I've got a root shell. So if you see here, I'm actually UID equals 0, root. So I've exploited, or I own that machine now. And then I just do sbin. Sometimes you got a limited shell, so you got to put the path in. If config, and there's the IP address of the target, and then I can try things like netstat-at, and there's my open ports on the target. As you see, there's secure shell that's open, HTTP that's open. All this information I can now validate and verify based on my testing that I did with my Nmap scan. So that's pretty much it. I've actually exploited this machine now. So I have this machine, it's exploited, I own it, and depending on my scope of work professional testing, it will determine what I can and cannot do. So that's the part of the demo that finishes. Now let's go to the close of the course. The close of the webinar, that is. We're not doing the actual course. So that brings us to the end of the demonstration. We're at question time. So normally what you do is you type those in or you ask them and we can ask later. And that's the last information about me and information you can do and connect with different things I've got with my LinkedIn. You can reach out to me on LinkedIn. There's my email address. You've got my custom pen testing platforms that I've set up now, the CSI SWAT, me and Wayne Burke, a good friend of mine. And you've got my two books, Advanced Penetration Testing course for the Center for Advanced Security Training and the Pluralsight Udemy course. And this concludes the webinar.